Ever pondered on the idea if humans could navigate the world using only the power of sound? Imagine a world where your ears serve as your eyes and sound waves paint a picture of your surroundings. This might sound like a page out of a sci-fi novel, but it's a daily reality for some creatures in the animal kingdom. Take bats, for instance. They navigate the night sky with a unique skill called echolocation. By emitting high-pitched sounds that bounce off objects and return as echoes, bats can see their environment with impressive precision. Dolphins and certain species of birds use a similar technique to traverse the vast oceans and skies. Now, what about us humans? Could we tap into this acoustic radar system and see the world through sound? What if we could use echolocation to detect obstacles or navigate unfamiliar spaces? It's a fascinating concept, isn't it? You may think it sounds like science fiction, but science says otherwise. To understand how echolocation works, we must first look at nature's masters of this skill. In the heart of the night, bats flit and flutter, navigating the darkness with ease. They're not just blindly winging it, though. They're using an incredibly sophisticated biological sonar system known as echolocation. Emitting high-pitched sounds, these creatures listen for the echo of their call. By interpreting the time it takes for the sound to bounce back and the change in its pitch, bats can construct a sonic map of their surroundings, avoiding obstacles and locating their next meal. It's not just bats that are echo experts. Let's dive beneath the waves, where dolphins dance and dart through the ocean's depths. They too use echolocation. Dolphins emit a series of clicks and listen for the echoes. Each click is like a pulse of sound that travels through the water, bounces off objects, and returns to the dolphin. By listening to these echoes, dolphins can determine the distance, size, and even the shape of objects around them. It's a remarkable skill that allows them to hunt in the murkiest of waters and navigate the vastness of the ocean. But how exactly does this work? Well, imagine you're in a room and you clap your hands. The sound waves from your clap travel out in all directions until they hit a wall or object and bounce back. The time it takes for the echo to return tells you how far away the object is. Now imagine being able to do this so precisely that you can differentiate between a small insect and a leaf in total darkness, like a bat, or distinguish between a fish and a plastic bag in murky waters, like a dolphin. That's echolocation in the natural world. A complex yet beautifully simple way that certain creatures interact with their environment. It's a testament to the wonders of evolution and the incredible adaptability of life on Earth. So that's how our furry friends do it. But what about us humans? Believe it or not, humans have the capacity for echolocation too. Now, you might be wondering, how does this work exactly? Well, sit tight because we're about to dive deep into the fascinating science behind human echolocation. You see, our brains are incredible processors of information. They take in data from our senses and create a picture of the world around us. But what if one of those senses is impaired or missing? Can our brains adapt? The answer is a resounding yes. This adaptability is known as neuroplasticity, the brain's ability to reorganize itself by forming new neural connections. This is where the science of human echolocation comes in. Some visually impaired individuals have mastered the art of using sound to navigate their environment. They create sounds, either by tapping a cane or making clicking noises with their mouths, and then listen for the echoes of these sounds bouncing off objects in their surroundings. This echo gives them valuable information about where things are in relation to their position. Here's the clever bit. Our brains are wired to interpret these echoes. The time it takes for the echo to return, the pitch, the volume. All these factors are processed by our brain to create a mental map of our surroundings. It's a bit like sonar used by bats and dolphins, but in this case, it's the human brain doing the heavy lifting. Now, this doesn't mean we can all suddenly develop daredevil-like abilities. Echolocation requires practice and a degree of sensitivity to sound that most of us aren't used to. But the science shows that our brains are capable of learning this skill, given the right circumstances and enough practice. So, the next time you're in a pitch-black room, why not give it a try? Make a clicking sound and listen for the echo. You might just be surprised at what your brain can do. Remarkable, isn't it? But how can we potentially use this? Imagine walking in a completely dark room without bumping into anything. Unthinkable? Maybe not. Now, let's delve into the fascinating possibilities of human echolocation. Think about what this could mean for us. Imagine being able to navigate through a dense fog, or finding your way in an unfamiliar place at night, all by utilizing the echoes bouncing off nearby objects. Imagine the freedom and independence this could grant to people with visual impairments. The potential uses of human echolocation are vast and varied. In professions where visibility is often compromised, such as firefighting or deep-sea diving, echolocation could serve as a crucial supplementary navigation tool. By interpreting the echoes of their own sounds, these professionals could better understand their surroundings, increasing both their efficiency and safety. Moreover, in the field of archaeology, echolocation could revolutionize the way we explore ancient structures. The echoes within old buildings or caves could reveal details about their structure and layout, without causing any damage to these precious historical sites. But what does science say about this? Well, the good news is that research into human echolocation is ongoing and expanding. Scientists are studying individuals who have honed this skill, trying to understand the mechanics behind it. They are also exploring the potential for training others in echolocation, with some promising results. A study published in the journal PLOS One found that, with training, sighted individuals were able to use echolocation to determine the location of a virtual object. This suggests that echolocation isn't just a skill for the few, but a potential tool for many. In another study, scientists used functional magnetic resonance imaging to examine the brains of individuals who use echolocation. They found that these individuals processed echo information in the visual cortex, the part of the brain typically associated with vision. This finding has opened up intriguing questions about the plasticity of the human brain and its ability to adapt and learn new skills. As we keep pushing the boundaries of what's possible, who knows what we might discover next? The world of echolocation holds a lot of promise, and we're just at the beginning. As we continue to delve deeper into the mysteries of this natural talent, we uncover more and more about its potential. Imagine, if you will, a future where technology and neuroscience have advanced to the point where human echolocation is not just a skill mastered by a few, but a common ability harnessed by many. Picture a world where we can all see with our ears, where darkness and visual impairment are no longer barriers to navigation. This is not as far-fetched as it might sound. Current research is already shedding light on how our brains can adapt to interpret echoes and sound waves. With the rapid pace of advancements in neuroscience, it won't be long before we have a deeper understanding of this process. And then there's the role of technology. We're living in an age where our smartphones can do almost anything. Imagine a device that could assist with echolocation, amplifying sounds or providing haptic feedback to guide our way. This isn't just science fiction. There are already prototypes being developed that aim to do just this. But it's not just about the technology or the science. It's about the potential benefits to society. Imagine how this could transform the lives of visually impaired individuals. No longer would they need to rely on guide dogs or canes. They could navigate their surroundings independently, giving them a sense of freedom and autonomy that many of us take for granted. Echolocation isn't just about seeing with our ears. It's about understanding our world in a whole new way. It's about challenging our perceptions and pushing the boundaries of what we think is possible. Echolocation, a fascinating blend of nature's ingenuity and human curiosity. Who knows where it might lead us? Only time and science will tell. We started this journey with a question. What if you could see with your ears? Indeed, the world of echolocation, once exclusive to bats and dolphins, is opening up to us humans. It's a testament to our ability to adapt, to learn, and to push the boundaries of what we understand as human capabilities. We've explored the science behind human echolocation, delving into the intricacies of sound waves and their reflections. We've looked into the potential uses of this fascinating skill from aiding those with visual impairments to offering new ways to navigate our surroundings. And we've peered into the future, a future where echolocation could become a part of our everyday lives. So, as we wrap up, let us remember that the bounds of human perception are not fixed. They're waiting to be expanded, to be redefined. If you made it this far in the video, a very special thanks is in order. Like this video if you learned something, and subscribe to our channel for more.